We got this crazy integral we're going to do, and it's actually not that bad. We're doing a trig sub, and I know I want to try a trig sub because I've got this square root and a sum of two squares. That's like screaming trig sub. And the steps are always the same at the beginning. We take this square root thing and call it something. I'll just call it g. Now we want to rearrange it so that it looks like the equation for a right triangle. A squared plus b squared equals c squared. So to do that, we'll square both sides, and that gives us g squared, and g squared equals 9 plus x squared. And then we'll just draw that triangle and put the g in the hypotenuse in this case. X and 3 are on the sides. It doesn't matter which side is which. And now our next step is to write theta in terms of x and theta in terms of g using SOHCAHTOA. So we'll use x, start with x first, and we want to use tan x. It's very important because it's opposite over adjacent. And that gives us theta in terms of x, but not x and g. So we want to have like x and the number, not x and g together. So we'll use tan theta equals x over 3. Now, so what's x? Well, if we multiply both sides by 3, x is 3 times tan theta. Okay, so that's what I have right here. Now, we know what x is. We need to know what dx is as well. So we'll take the derivative of this with respect to theta, and then we'll rearrange so that we get dx equals 3 secant squared theta d theta. And that's it right there. Okay, so now we need to know theta in terms of g. We'll use cosine because that gives us the number and g together, adjacent over hypotenuse. And yeah, so that's our g. Now we look at this carefully, dx is in terms of secant theta, right? And x is in terms of tan theta, and g is in terms of cos. So we got like 3 different trig functions going on. But we know that 1 over cos is secant. So I'm going to write g in terms of secant. We multiply both sides by g, divide by cos theta. That's 1 over cos, but 1 over cos is secant, which I have right here. So now we'll do the substitution. And if we do that, dx is our 3 secant squared theta d theta. Our x is 3 tan theta, so that's 3 tan theta squared. And then our square root thingy, that's g, which is 3 secant theta. And things cancel pretty nicely, and that's what often happens with these trig sub integrals. That makes our life easier, or hopefully it will make our life easier. After we do the substitution, things cancel out. So if we cancel out one of our secant and cancel out one of our 3's, 3 in the numerator, one of the 3's in the denominator, we have this right here. We have a secant left in the numerator. We have 9 in the denominator because it's 3 squared, and then a tan squared as well. Now, at this point, there's a variety of ways to do this, and let me know if you have a faster method for this. But what I done is I just broke things down into sine and cos, and it might not be the fastest way, but kind of when in doubt, go to sines and coses, and maybe you can see the way out. So I converted secant theta back to 1 over cos theta, tan into sine over cos, and with the substitution, this is what we have here. 1 over cos is secant, tan squared is sine squared over cos squared. So one of these cancel. We can multiply top and bottom by cos so that this bottom cos cancels, but we still get a cos in the numerator right here. Or you can think of it as like kiss and flip, some people call it. Okay, now at this point, we're in maybe very familiar territory with the u-substitution because the derivative of sine is cosine, which we have right up here. So if we have the derivative of a function within this integral here, it's often screaming a u-substitution. So we'll do that. We'll set u equal to sine theta, take the derivative with respect to theta, and rearrange to get du equals cos theta d theta. And we could sub that in. So du is now in the numerator because that's cos theta d theta. Our u is sine, so sine squared is u squared. And yeah, we can reverse power rule this. This is like u to the negative 2, so we add 1 to the exponent. And then we got to have a negative here to account for the fact that if we were to go the other way, reverse chain rule, we'd need a negative to cancel out. And plus our integration constant here. And that's basically it. It's in terms of u, but we need to go back to x. So u we defined as sine theta. Now, that helps us. That goes from u to theta, but we want to write things in terms of x, right? So how do we do that? Well, we go to the right triangle. And this is the right triangle that we originally set up. We want to know what sine theta is. Sine theta is opposite over hypotenuse, which is x over g. So that's literally what sine theta is, x over g. And we can substitute that in for u. U is x over g right there. And we have this fraction inside a fraction, this compound fraction, so we can like kiss and flip it again. And then for our final answer, we want to write everything in terms of x. So we'll substitute what g is, negative square root of 9 plus x squared over 9x plus our integration constant. And we're done. Next integral, please.